This video contains the solutions to take-home problems number 19. For these first two problems, we're just asked to graph a few functions from our library of functions. So in this case, the fifth root of x, what we need to know is the general shape of root functions, but also the fact that since we have an odd root, what we're going to get is a function that exists for positive and negative values of x. So it's going to look like x to the fifth, but it's going to be tipped over onto its side so that it looks like that. It goes to the point 0, 0, and it goes up pretty quickly at first, and then levels out as it goes to the right. Same thing as I go to the left from the origin. It goes down pretty quickly at first, but then it levels out as it goes to the left. So that's the general shape of the graph of fifth root of x. For 1 over x, again, what we need to know is that as we approach 0, the y values shoot up to infinity from the right of 0, and then shoot down to negative infinity to the left of 0. And then as we go either to positive infinity or to negative infinity, the y values get closer and closer to 0. So that's what that graph looks like. And then finally, for the absolute value of x, this looks like two lines. Remember that the absolute value is really a piecewise function. So it's two lines, one with slope positive 1 and one with slope negative 1, both going through the origin 0, 0. All right, now we want to solve some equations involving roots and absolute values. So the way that we deal with this, an equation that has a square root in it is that we want to square both sides to get rid of the square root. So we're going to take square root of 3x plus 1, square that, and 4, and square that. And when we do that, we get 3x plus 1 equals 16. Subtract 1 from both sides, divide both sides by 5. And whenever we do this, we want to go back to the original equation and make sure that the solutions that we got really do work with that square root. Because when we get rid of the square root, we lose the fact that this number, 3x plus 1, is not allowed to be negative. Once we get rid of the square root, we no longer have that restriction on what that value can be. But if we go back and plug 5 in to check this, we find that 3 times 5 plus 1, does that equal 4? Well, it's the square root of 16, which does in fact equal 4. So this checks out, and so that's our solution. Here we have a slightly different problem where we have a square root, but now there's an x on the other side of the equation outside the square root. But we're going to approach it in the same way. We're going to square both sides, 2x plus 5 squared, and then x plus 3 squared. So on the left-hand side, the square gets rid of the square root, and on the right-hand side, we have to actually multiply out x plus 3 times x plus 3. When we do that, we get x squared plus 6x plus 9. Again, remember, whenever you have an expression like this that you're squaring, you don't just square the x and square the 3, you actually multiply it out, in this case using FOIL, and that gives us our x squared plus 6x plus 9. All right, now we've got a quadratic equation, so we're going to move everything over to the right-hand side. We get x squared plus 4x plus 4. That's going to give us x plus 2 times x plus 2 when we factor, which means we have two solutions, but that's really the same solution twice, x equals negative 2 and x equals negative 2. When we check that, it does check out, and so our solution is x equals negative 2. We don't have to list that solution twice because it either is a solution or isn't a solution. So just x equals negative 2. All right, now I've got an equation with absolute values. And so what we have to realize is that this number on the inside of my absolute value, 4x minus 5, must either be 13 or it must be negative 13. If it's 13, then the absolute value doesn't do anything, and that's why the absolute value of 4x minus 5 equals 13. But if it's negative 13, then the absolute value gets rid of that negative, and that's what gives us the 13. So that gives us two equations. 4x minus 5 equals 13, or 4x minus 5 equals negative 13. So for this first equation, I add 5 to both sides, 4x equals 18. Divide both sides by 4, I get 18 over 4, also known as 9 over 2. On this second equation, add 5 to both sides gives me negative 8. Divide both sides by 4 gives me negative 2. And again, we should go back and make sure that these really do work out, but we check and then they do. And so our solution set is 9 halves and negative 2. finally, this problem 3b is kind of similar to the problem 2b, where we have a square root but also an x outside the square root. Here we have an absolute value and also an x outside the absolute value. So if we try to solve this, again, we're going to get a similar result because 5x plus 2 either equals 2x plus 1 or 5x plus 2 equals the negative of 2x plus 1. Those are the two possibilities when we have a square root. So for this first example, 5x plus 2 equals 2x plus 1, we subtract 2x from both sides, subtract 2 from both sides, divide both sides by 3, we get x equals negative 1/3. For the second example, 5x plus 2 equals negative 2x minus 1, add 2x to both sides, subtract 2 from both sides, divide both sides by 7, and we get x equals negative 3/7. Plug those back into the original equation, check to make sure they work out, but they do, and we get that our solution set is negative 1/3 and then negative 3/7.